what I wanted to talk about today was largely work that was driven by a recent publication that I worked on in collaboration with a lot of folks who you can see here. And this, the bulk of the material here, I'll just say up front, is in this recent paper. So if you would like any more information about it, you can look it up or you can contact me if you'd like a copy. But Malcolm North was the lead on this. He's a Forest Service researcher with Pacific Southwest Research Station based in Davis. And I also want to acknowledge David Green, who did a lot of work in sort of pulling together some of the ideas for this. But the title of the paper and really the focus of what I'd like to talk about today is Reforestation for Resilience in Dry Western US Forests. And really, as the title of the talk suggests, what we're hoping to focus on is building early resistance through the way that we plant after disturbance. And so the motivation for this largely comes out of what we're increasingly seeing as the ecological impacts of modern wildfire, and specifically changes in the amount and size of high severity patches that require reforestation. So we're all familiar with seeing maps like the one shown here, which is the King Fire from the Sierra Nevada in California, where we've got large patches of red. And the red represents high severity fire. I assume most folks on this call are used to looking at burn severity maps like this, but that's essentially areas where the forest has been completely removed. And what we've seen in analyzing trends from California specifically, where the bulk of the research presented here has taken place, is really an increase in high severity burned areas beyond reasonable limits of conifer seed dispersal. And this figure here is from a paper published a few years ago, where we looked at the cumulative area that was greater than, I think, about 150 meters from a high severity patch edge as you move inward from the patch edge. And you can see that there's considerable acreage. This is hectares shown here, but we're looking at, over 60,000 hectares in high severity. That's, beyond a reasonable dispersal distance just since 1985. And so we're seeing, there's lots of good quantitative evidence, both from California and from across the Western US, that we're seeing increases in the percentage of high severity fire, which often averages above 35%, where a historical range of variability may have been more around 4 to 12%. And arguably more importantly is that we're seeing increasingly large patches. And there's some data in that paper as well about that. But in exceedance of 400 hectares, where a historic range of variability would have rarely exceeded 4 hectares. And the implication is that the interior of these high severity patches is well beyond conifer seed dispersal. And that's not to say that there aren't occasional instances of this, and the relative likelihood of this is an area of, I would say, ongoing research. But there's quite good evidence that natural seed dispersal into high severity patches is limited. And from a forest ecology perspective, this has implications, the leading one of which is that without a planting effort, many of these areas may become long-term shrub fields, or depending on what sort of early successional vegetation follows fire in your region, maybe they'll become perennial grasslands or some other vegetation type. And another implication is that if we're considering, the desire to reforest large burned areas, that's something that requires material investment. And so we really have an increased need for seed collection and for seedling stock in order to accomplish that planting. And then finally, one of the things that's going to be a central theme here is that often, because of limitations to what we can do after an initial planting effort, the pattern that you plant often may end up being the pattern that you get. Fire is not the only stressor that faces Western conifer forests. In many regions, drought is also a big problem, partly due to that altered forest structure that's been well documented of increased density and effectively having too many straws in the ground. There's lots of great examples of this from the Southwest, including droughts from the 1950s and early 2000s that have caused extensive tree mortality. One of the most recent and best documented examples is from California and the drought from 2012 to 2016, which, depending on the metric you use, was the most or among the most severe droughts in the last 1,000 years. And cumulatively in the Sierra Nevada, the 4-year drought plus delayed mortality, even once precip picked up again, was over 150 million dead trees. And some work that I was involved with that Derek Young led in a paper in 2017 showed that the spatial patterns of this mortality was very strongly correlated both with the regional sort of mean climatic water deficit, the average water demand of a site, integrating temperature and precipitation, and also the stand basal area. So the amount of transpirational demand, which is closely related to stand basal area, is positively associated with the amount of mortality that we saw. And of particular concern is that mortality is largely proximally caused by beetles, and they tend to attack the larger trees. And so we're seeing, in particular, the loss of large old growth trees at a rate even exceeding background rates, which are also increasing. So the question that we asked to motivate this paper is whether traditional reforestation practices, which, a shorthand for that is pines and lines, which some of you may have used or heard of, whether that is well adapted to increasingly common stressors like fire and drought. Just to kind of walk through some of the principles behind traditional reforestation practices, there's lots of good forestry research over decades to centuries of how to do this efficiently. And I think it's a pretty well-honed science at this point. And it absolutely has, relevance in a lot of reforestation efforts. But the principles behind it are to bypass that sort of uncertain natural seeding that I was talking about earlier, which in obligate seeding forests, or in forests that have to disperse rather, to establish is driven by patch size. And then once, even if you get natural recruitment, that seedling stage is quite vulnerable. And so planting efforts are designed to bypass that vulnerability by increasing or by initially, growing out seedlings in a greenhouse setting and then giving the seedlings a heads up. And so there's site preparation, as you see here, that's often involved with that to remove, fuels and competing vegetation from around the area that seedlings are planted. And then once the pines go in the ground, or once the trees go in the ground, we'll show pines in all of our examples here today, the expectation is that you get rapid height and diameter growth for on the order of 20 years, or more or less, depending on your sort of site quality. And part of that process is that eventually the crowns interlock and control light resources. And so that has, the advantage of sort of promoting additional capture of the site, maximizing growth and yield, and then eventually the idea would be to go in to a regularly planted stand and do some sort of subsequent density management. So it's sort of a pre-commercial thin to remove trees to increase the growing space once the crowns have started to interlock. This focus on planting at high density is understandably often driven by a desire to shade out competing vegetation. And there are good reasons to do this from a sort of a growth and yield perspective. You can see there's data here and good data elsewhere from the Southwest that your height growth is expected to be greater in the years following planting, the less competing vegetation, in this case brush, call it what you will, that you have on the site. So you can imagine, in a post-fire landscape where brush is significant, growth may be substantially reduced, especially in early years by competition for light and then eventually competition for water as well. So this is, as you might have guessed from the group of authors and from my background, this is a bit of a California-centric talk, but I think it'd be interesting to think about some of the similarities and differences to Region 3 in the Southwest. But here are the recommended stocking guidelines by species and site class for the Southwest. And you can see, recommended trees per acre. Obviously, there's a recognition that that's going to depend on site quality, but generally planting guidelines suggest between 150 and 300 trees per acre with some flexibility. Now, it's worth contrasting that with information on the historic range of densities that we see based on sort of historical timber surveys and dendrochronological reconstructions. You can see, again, there's some variation depending on vegetation type, but we often saw mature tree densities on the order of 50 to 70 or so trees per acre with a considerable range that's going to be driven by local factors. So there's a bit of a discrepancy there between sort of recommended and even minimum stocking guidelines and what frequent fire forests would have had historically. And so the motivation for this came out of some observations from a number of the folks who are on the paper, including a few silviculturists on local forests in California, that recognize that this method of traditional planting is heavily dependent on that subsequent intervention, the course correction, the ability to go in after the initial planting and sort of tweak the landscape to more accurately represent a desired condition. And so this PCT, or pre-commercial thinning, is often a key step in this process, which reduces density, changes composition, and changes the spatial pattern. And so, the mindset is one which is reasonable, that we can go in and sort of create the heterogeneity that we want after we first capture the site with trees. Part of that capture, of course, is reducing early shrub establishment with herbicide and or grubbing, mechanical removal. But you can see in the figures below that without that course correction, which again is costly, we can get a pretty undesirable condition ecologically, where we have a high crown contact and relatively little diversity in the understory. And the other, I think the overriding concern here is that there's been a 93% decline in annual acreage released across regions 1 through 6 in the Forest Service. This figure is in that paper that I mentioned up front. But you can see the tree release treatment, down from around 15,000 hectares to less than 1,000 in 2017. There's also been a decline in planting, but there's a backlog of planting that has not really been either released or pre-commercially thinned. There was a pulse of pre-commercial thinning in the late 90s and early 2000s, but again, the pre-commercial thinning has been reduced by about 40% by 2017 from its peak. And one of the consequences of this is that if you end up with a high density plantation that has not received subsequent treatment, there's a lack of resilience in that resulting forest structure to things, including fire, where we have a number of documented instances of fire entering a plantation as part of a wildfire that was burning the surrounding landscape and leading to 100% mortality, or near 100% mortality in some other instances, due to the interlocking of the crowns and the foliage on the edges of the plantations reaching the ground and facilitating, fire spread into the crowns. There's also reduced resilience to drought. As part of the recent drought in the Sierra Nevada, there was considerable drought in some post-fire plantations that had been planted in the 1970s and 1980s. One of the reasons for that is that there's not really any variability in the resource capture area. So if you're planting in a gridded fashion, then the competitive environment for every tree is more or less the same. And if you haven't done any subsequent density management, then you reduce the precipitation inputs, you increase the competition, and there's going to be some losers in that. And the other issue is that in often what are planted are desirable commercial species, ponderosa pine being preeminent among them. And if you're only planting one species, then you don't necessarily have the hydraulic diversity that you would want to promote drought resilience, where you have different species that may have different phenologies of water use, different rooting depths, et cetera. So overall, we argue that regular spacing is understandably developed for good reasons from a production strategy for maximizing growth, but it's not necessarily the best strategy to increase resilience to future disturbance or stress. One of the guiding principles for restoration in dry mixed conifer forests across the Western United States has been a really increasing recognition that resilience is associated with fine-scale heterogeneity. So within stand, sort of sub-hectare variability in tree density and clumps and gaps. So a common term for this is the ICO, or individual trees, clumps of trees, and openings patterns. That was first introduced by Larson and Churchill. And there's lots of good examples from sort of restored forests, including the photo in the lower left from the Illilouette Creek Basin in Yosemite National Park, that sort of shows what this pattern looks like in a mature forest. There's, in addition to visual evidence, there's good quantitative evidence of what this pattern looked like. These are data from the Stanislaus Tuolumne Experimental Forest in California, where some plots that were targeted for thinning in the late 1920s were first stem mapped. And so we have great data on what the spatial patterns of these 4-hectare plots were from the stem maps. And you can see this is a 4-hectare plot shown here. And of all the different sort of group sizes from single trees to 10 or more trees per group, there's actually only about 13% of the trees in this 4-hectare stand that were occurred as single stems without a interlocking crown. And then there were there's considerable area in clumps of 10 or more trees. So high variability across the landscape. And also across this landscape, over 50% or approximately 50% of the area was in gaps. So here's our sort of target for restoration, this ICO pattern. And there's another sort of paradigm underlying this, that in active fire forests, that structure, the local density, composition, and structure are influenced by water availability and fire, but those are mediated by topography. So we have a pretty good idea of how topographic variability should influence density in basal area. Examples in this figure show, reduced densities on ridge tops, increased densities in concave slopes, drainages, valley bottoms, and also a difference in composition with generally less drought tolerant, more shade tolerant species occurring in the denser parts of the landscape. So if that's our sort of target for restoration and forest resilience to subsequent disturbances, we argue that there should be 3 main objectives as part of a reforestation plan for a resilient landscape. This is not to say that this is the strategy for a production landscape, but that's one of the important questions that we should all be asking, is what is the objective of our reforestation effort? So the first of these 3 is to divide the reforestation area into zones by potential seeding and access. So this is really asking the question of, where does it make sense to plant, and in what ways do we want to plant different parts of the landscape? Secondly, in areas that we decide planting is warranted, that composition, density, and spatial pattern should vary, and to the extent possible should be aligned with microsite water and fire patterns. So harkening back to that previous slide where we looked at sort of a schematic of landscape diversity, we try to recognize what the forest will eventually look like and get it started in that direction from our planting patterns. And then third, we suggest that it's time to start at least considering the possibility of building young forest resilience with the use of early, frequent prescribed fire. So basically planning for fire to enter plantations at some point in their lifetime. And if we plan for that, we recognize that maybe the earlier that we get it in, the more resilience will be baked in from the initial stages of development, stand development. And so sort of summarizing these 3 objectives, the first one I think is really asking the question of whether to plant and where to plant. So these are, questions that are worth asking, especially in light of limited resources to accomplish planting. It doesn't make sense to plant everywhere, and where it does, we need to think about, where on the landscape we will get the most bang for our buck. The second is really how to plant. So it's thinking about, what the ultimate structure we would like to get is, and trying to set the stand on that trajectory from our initial planting pattern. And then third is just one piece. This use of fire is one piece of a broader question of why to plant. So, again, from a production forestry perspective, prescribed fire is going to probably kill some trees, and we probably want it to. But that may not be part of the desired objective in that situation. But if restoration is the primary objective, then maybe it is. And so it's, again, just important to ask the question of why are we planting? These 3 components of this strategy really, I think, closely relate to something called the target plant concept, which if anyone heard Owen Birney's webinar in this series last month, it was discussed at length, and it's I think a useful way to sort of structure our thinking about planting decisions. And so just wanted to put that in some context there. But again, here is sort of our ultimate goal is to create a stand, at least from an ecological perspective, it's to create a stand that has high spatial variability and as a result has some resilience to fire and drought. And this is just an example on the top from another nice reference condition, at least for the Sierra Nevada, which is the Sierra San Pedro de Martir in Baja California. So here's one illustration of how the first, so let me just remind, we have sort of on this previous slide, a when and where component, a how and a why. So the first of those is where to plant. And we suggest in this paper, which I think is probably implicit in many decisions that are already happening across landscapes, but really thinking carefully about different planting zones. And so just as one example of how this might work, we suggest 3 zones where the first of which is really limited, no to limited planting in areas that are within seed dispersal distance of live trees. So there may be some interplanting that's warranted, but largely I think the idea would be to let natural dispersal regenerate those areas that have a high likelihood of natural dispersal. Secondly is sort of maybe the most intensive zone for planting, and this would be areas that are accessible for salvage if that's a desired pre-planting treatment, and then for eventual planting. These would be areas that have some road access and yet are beyond a reasonable distance for seed dispersal. And then third, it's, I think, implicit also that some of the more remote stands will not be at least intensively planted, but I do think it's worth at least considering doing some founder stand, or sort of a nucleation strategy, which is another term that Owen used last week in his talk, or last month. Planting pretty low density stands, but just getting some trees out into remote inaccessible areas. Again, there are obvious cost and safety challenges associated with this, but if a remote area is identified as a valued part of the landscape and forest is desired eventually, then getting at least a few trees out there that can survive and make it to adulthood while surviving subsequent fires would be the third leg of that stool. And this landscape, just for reference, is a 2-year post-fire image from the Eiler fire, which burned in Northern California. Secondly, the proposed planting schematic really, again, tries to take into account topographic heterogeneity and in the initial planting design. So the idea would be to plant sort of at a most simple pass would be to plant clusters of seedlings where there is likely to be more water. So these would be local concavities in the landscape, toe slopes, convergent drainages where there's quite a bit of sort of upstream water moving in the subsurface down through an area. And then we want to vary the species composition with how we think subsequent fire might behave. So planting more fire-resistant species, particularly ponderosa pine, in areas that are likely to see more frequent fire. And then in the interspaces between clusters, there would be some regularly spaced seeding. So we wouldn't be getting entirely away from regularly spaced seeding, but that would sort of be the matrix. And then you would insert gaps as required. So in this schematic on the right, this is just sort of an illustration from the paper of how this might work. And so this is an example half-acre landscape that's planted sort of on the low end of the recommended guidelines of trees per acre, but still above the minimum, depending on your site quality. And so this planting was 164 trees per acre in this example. And then in this example, we implement a prescribed burn through the landscape and also allow for some natural mortality that brings the trees per acre down to around 130 after 18 years. But then importantly, that fire is continued, and through repeated fire, we bring the trees per acre down further to around 86 after 80 years of repeat fires. And at this point, you can see how sort of those concavities would be developed into sort of denser stands. Some of them may go in the fire, and that wouldn't necessarily be a bad thing, but you end up with a highly spatially variable landscape. And again, this is what we might like that landscape to look like. You can see on the bottom center there is the Beaver Creek Pinery. It's an area in the Ishi Wilderness in the northern Sierra Nevada, ponderosa pine black oak forest. And then finally, this idea of using prescribed fire on plantations has a number of obviously challenges, but a number of potential benefits too. I just wanted to touch on briefly. Here are a couple examples of a prescribed fire in a young stand from the Shasta Trinity National Forest, pre and post fire on the left and right. And you can see that surface fuels were reduced in this prescribed burn, and there was some mortality, but there's also survivorship among that regenerating class 33 years after planting. So and part of that fire was obviously to raise the height of the live crown base in some of the trees, and that'll, we hope, promote a much more resilient structure to subsequent fires, whether they're wildfires that happen to enter the stand or additional prescribed fire. Here's another example following a 25-year-old plantation that was burned. That did actually kill some more trees than in the example above, but we think that this acted like a cost-effective pre-commercial thin that reduced that natural recruitment density. Again, if the goal from a pre-commercial thin is to actually get some sort of value out of the smaller diameter trees, then this might not be desirable. But if cost is the main driver and it's more effective to do a prescribed burn through this landscape than to get machines in there, this is, I think, an option that should be on the table. Another potentially utilized benefit of prescribed fire, or maybe under-acknowledged benefit of prescribed fire in early developing stands, is that fire has obviously been a strong selecting force in Western forests for millennia. And part of that selection is to favor the more fire-resistant trees. And so if we put that selecting force back in to young stands, that may favor phenotypes, and to the extent that those are genetically controlled, genotypes for future stand development and regeneration that have thicker bark and earlier branch abscission. So just to kind of sum it up, the main argument for this paper is that to promote resilience from reforested landscapes, reforestation practices should consider at least consider using ecological principles where appropriate. These include varying the density, composition, and pattern of planting with water ability and likely local fire behavior, and working with shrubs, so recognizing their competitive role, but recognizing also the potential value that they have as a heat sink in prescribed burning done under appropriate conditions, and also as a habitat feature of the landscape, where you may not want a completely barren understory of your planted stand, and yet you may want a more variable understory diversity component. And then that initial planting pattern we think is important, and frequent burning can reinforce that initial planting pattern to foster resilient stand development and spatial patterns without necessarily depending on costly future treatments or hoped for commercial thinning to adjust that stand development. Now, again, that's obviously a tool that's going to remain in the toolbox. And so it's just a question of sort of when and where is it appropriate to do one method versus another. And then I think the overriding theme here is that we want to make decisions keeping in mind that we're facing a future that's going to have increasingly frequent fire and increasingly frequent drought, and sort of take that as a given and just think about how that should influence our decision making and be a little bit strategic about it when and where that's possible. So with that, I'm happy to take questions, and thank you very much.
Well, thank you, Jens. That was a great presentation, and I think one of the things I really liked about it is it's clear and lays out in a way that even I can sort of remember and keep in my head. So let's see, we haven't had any questions come in the chat window yet, but I would encourage people to type questions or comments in as they can. And I got a side message from one of the participants who was actually involved in one of the fires you mentioned. I wonder if you would be willing to, I unmuted you so you could maybe share just your personal story, Kendra.
Can everyone hear me?
Yep.
Mm-hmm.
Hey, hello everyone. So yeah, you pulled up the Baldwin Eiler fires, and I was like, wow, that was my stomping grounds. I was the forester on the Lassen when I saw the lightning strike that started, and we were cleaning that up. Yeah, it was nuts. The Washington office was out too, so it made for a good show for DC folks. So I have to say, I feel very vindicated because the moonlight fire on the Plumas, our neighboring forest to the south,
Yep.
was one of the starters on the concept of cluster planting. And some of the younger foresters on the Hat Creek Ranger District, we jumped all over that and said, this is the path forward. Cluster planting really made a lot of sense, and it was showing a lot of promise on the reforestation and the moonlight fire. And this this is exactly what we said. Instead of the pines and lines, let's cluster plant the honey holes and do a broad, maybe 12 by 12, 16 by 16 overlay, just to, sort of fill in the gaps and give everyone that ease of transition, because cluster planting especially, when you've been so ingrained with pines and lines, it can be really hard to walk away from that. So yeah, we always went for honey holes and tried to do some cluster planting in there. But the reason that we didn't apply that strategy broadly is it became kind of hard to explain. This might have just been an isolated incident, but to try to write a prescription for the contract planters that you have coming in, it can be a little difficult for them as well, because they're very used to getting awarded a contract. It's going to be 8 by 8, 10 by 10, whatever. So it became kind of hard to communicate that end state to get it. And for us, I guess that was the reason that I was told we couldn't move forward with what I considered this like awesomely new, cool, novel planting that I wanted to do across the landscape. But 5 years later, I'm feeling very vindicated. So thank you for that, if nothing else.
Well, great. And I can just tell you, I don't know the current status of this, but I know that before I left California, Malcolm, and I don't know if you know Malcolm, he was starting an experiment on the Eiler fire to do some cluster planting,
nice,
sort of,
good.
or variable density planting, and a sort of groupy, gappy kind of orientation. And so I do believe that experiment is underway. And if you want to afterwards, I can maybe put you in touch. But yeah, the operational side is definitely a challenge. I think that's one of the reasons I think why the traditional planting has stuck, is just that it's very straightforward. It's very easy to train up a crew to do it who may have varying degrees of experience. And yeah, so it's something I think that people are continuing to think about. One thing that I've thought about, and haven't really done any implementation on, is to sort of use a grid template to draw up a planting plan, but instead of just every dot on the grid is a tree, some dots are 3 trees and some dots are 0 trees, and so you're still kind of moving in a grid in the field, but you're actually and so I think one of the cool areas for additional development might be sort of the integration of technology into that, where you would have like a tablet or some kind of app out in the field, and you're sort of, with a GPS attached or separate, you're sort of moving along the grid. And every time you get to a node in the grid, you look at your tablet and it's either a 0 or it's a 1 or it is a 4. And so there's some work going on in that app development world for thinning. There was a paper that I think Andrew Larson and Sean Geronimo and some others put out earlier this year to sort of to develop an app for thinning in the field to achieve that ICO pattern, where you're marking trees, and then you're constantly checking in. You're basically entering into the app every time you mark a tree, and you're kind of constantly updating your result, your leaf tree density and basal area, and seeing if you're hitting your targets while doing it in a more variable way. So that could be one area to make it a little bit more operationally feasible, but I'm sure there are others, and I think that'll be interesting to see those conversations develop over the years.
Yeah, I'm just stoked that we can get away from the pines and lines. So yay! I mean, this is great. I'm glad to know there's a future even after I left Lassen. So thank you.
Thanks for the question.
Well, and I'll abuse my privilege as presenter here to mention, what my organization, the Forest Stewards Guild, one of our things is connecting with communities and kind of a restoration economy view. And I do feel like there are a lot of people thinking this way. And I think across the West, integrating just the way we did with prescribed fire and are continuing to do with prescribed fire, we need to build crews and have it part of a workflow that they're folks who get the idea of these clusters and, you know, can identify the honey holes, et cetera. You know, and the culture of fire and prescribed fire is changing, and I think it'll take a while, but we can also change the culture of planting in a similar sort of way. But I should turn to one of the questions here in the chat window instead of my own interests. Catherine asks whether you're considering the probability of seedling survival when planning where to replant in areas that had low survival, even using some of these techniques. We might not have good survival. And do you have a way of to choose planting units based on likelihood of survival? So maybe that feeds into some of that app development you just mentioned.
Yeah, who wants to develop that app? I think there are sort of general guidelines that have to do with sort of a topographic water availability model. There are ways in GIS to sort of model subsurface water drainage with like a topographic convergence index. But even just sort of eyeballing it out in the field, you know, the most vulnerable areas would be ridge tops, because the only water they're going to get is what falls directly on top of them. And then as you move towards, you know, concavities and drainage bottoms, there's going to be additional water transport in the subsurface. Now, in early seedling development, that subsurface water may not be that useful, and it may still be driven by local precipitation. And obviously, this is something that we've talked about as part of the Burned Area Learning Network field trips that have been going on in the Southwest over the last several weeks. And there's another one upcoming that I think some folks on this call are going to be participating in. But there is the temporal variability piece is a challenging one, just because, you know, there's a lot of infrastructure that goes into developing a planting effort that involves, you know, ordering the seedlings, rearing them up, and then hiring the crews and then planting them out, and that all takes several years to develop. And so you can end up in a situation where, you know, you've developed a great planting plan and you've done some of this variability, you know, planning, and then you just end up planting in a drought year. And it was mentioned, the Moonlight Fire was mentioned earlier in California, and that's, I think, a nice example that I'm personally familiar with, where there was some cluster planting done, but it had high mortality just because the year that it was planted out, you know, was a pretty significant drought year. And so there was high failure in that planting. So yeah, I don't have an easy answer to that, but one thing that we've sort of been discussing casually in these field trips is a lot of what I've presented here today is sort of a spatial variability perspective, and we're sort of bet hedging across space by, you know, planting at lower density, and hopefully the trees that are in the favorable sites are gonna survive. But there may also be room for some temporal bet hedging, and this is challenging with the infrastructure requirements around planting for sure. But you know, if perhaps a plan development calls for planting half of a project area in one year and half in another area, that may allow for some flexibility just in the unpredictable, you know, what's the next year precip going to look like, or what's 2 years precip going to look like. And so that's something we've been thinking about. Obviously there are challenges with it, but maybe something to keep in mind.
Yeah, thank you. Bill asked a question about, or maybe it's more a comment, those shrub fields are valuable components of the landscape in dry forests. From fire exclusion, we need to repay that climate and fire debt and restore a landscape to a mosaic that includes non-conifer vegetation, including chaparral. Shouldn't reforestation also include not replanting forests where they should be?
I absolutely agree with that. I think, at least in principle, now there may be, you know, disagreements when it comes to actually evaluating a patch of ground, but I think that part of the decision about whether to plant which was one of the kind of the legs of the stool that I identified somewhere in this talk, this first piece here, is an evaluation of what, you know, where do we want forest on the landscape going forward. And it just so happens that at least in California and in some of the places in New Mexico that I'm familiar with since my time here, a lot of the inaccessible areas are sort of steeper slopes surrounding, you know, canyon bottoms, drainages, and often south-facing slopes. I think those are pretty obvious places, you know, south-facing slopes that are steep and inaccessible, where even if there was forest there previously, there are both, ecological and logistical reasons to not try to get forest back in there. And so, that would be sort of just an offhand way to evaluate different parts of the landscape that we don't necessarily want to plant. But I absolutely agree that, that should be a factor in the decision of whether to plant in certain places.
Yeah, thank you. And yeah, let's see. I guess I wanted to turn to John, and I'm going to unmute you here, John, and see if you wanted to ask a question just verbally.
Sure. So, quick bit about myself. I'm developing reforestation projects in the Western United States and registering them as carbon offset projects. And to fund these projects, I know one of the biggest problems to do all this is the actual the funding cost. And so we're partnering with corporations, foundations, high net worth individuals to fund these and create a long-term investment opportunity, leveraging the carbon markets. And so one of the questions that we always get, usually it's the most common, and right off the bat is, well, what happens if the forest just burned down again, in 5 years or 2 years or 10 or whatever. And it would basically kill the project. And so I'm searching for better and better answers all the time to respond and how the future practices of forestry and the setup of this. And so I'm just curious what you think, how I can add to that. I mean, I'm not a forester by profession. And so
sure.
I'm still trying to build that. What are your thoughts there?
I think that's a great avenue to explore for additional funding. And I think that one of the arguments for doing sort of a lower density and variable density planting is that the trees that you do put in the ground have a higher probability of making it to some mature state where we can count their, annual carbon storage as part of a long-term carbon credit kind of accounting. I haven't done much work on that personally, but I think you might be interested in some of Matt Hertaugh's work, who's at UNM, University of New Mexico, surrounding the idea of a carbon carrying capacity, where there's modeling that you can do sort of using information around historical forest density and structure to sort of put a ballpark estimate to how much carbon can reasonably be contained on a landscape. And that is probably below what you could actually get if you just completely suppressed fire and planted a high density and got more trees on the landscape. Like if you tried to make Sierra Nevada or southwestern forests look more like the West Slope of the Cascades in Washington. But then obviously that's not going to be successful in the long term because of the changes that we're seeing in fire severity. So there are ways to estimate for sort of a given site productivity what the carbon carrying capacity of that would be. And then that could factor into sort of an accounting project that would fund reforestation that would maybe use some of these methods to achieve that carbon carrying capacity. Hope that's helpful.
Yeah, I think it is.
Yeah.
And I think that's a really fruitful area for further conversations, and something that I think both the consortium and the Burden Area Learning Network would be interested in organizing around.
Great.
Yeah, perhaps we can take it offline somewhere in the future and just take that conversation forward. Thanks.
Yeah, feel free to email me. I'll pop up a slide that has my email address on it again.
We had another question from Maren Chambers about survivorship. I may have missed this if you already mentioned it, but do you have data or insights on what kind of planting survivorship there is in this region, the Southwest?
That is a good question, Maren. We are, and I think you're involved in this conversation, even maybe with Paula Fornwalt from Rocky Mountain Research Station, interested in collecting some data from different national forests in the Southern Rockies on previous plantings and looking at survivorship data from those plantings and seeing how well we can relate that to both sort of topographic variables and climate variables having to do with the year that they were planted. So I'm familiar with a good amount of sort of natural regeneration survivorship data from California. In terms of plantings, that's something that, yeah, we're trying to get a better handle on by teaming up with some national forests here in the region. So it's obviously, I think, going to depend on, there's definitely going to be an influence of post-planting weather. And one of the things we're interested in is seeing how strong those relationships are. And so I guess stay tuned and talk to Paula and I next week at the Hayman Fire about the details of that.
Great. So I think we got through the questions that were in the chat window. Please feel free to add one or two more. We're coming up on the top of the hour here. And I'll give folks another second here to type in. This has been a little bit of a series on planting and regeneration. And so another thing that you could type in the last 2 or 3 minutes here is if there's another angle on this topic that we haven't covered that you feel is right for discussion, or if there's new research that you're working on or you've seen, that would help. Okay, well, I'm not seeing anything else pop up here, so I think I'll just take the opportunity, Jens, to thank you again. It's great. Not all of us have time to dive into these research papers, and having a nice multimedia presentation of them is maybe more digestible, at least for me. So I really appreciate you taking the time to share your work with us. And all the folks on the line here, all our participants, thank you so much for joining. And I hope you'll join us on future webinars, and do get in touch if you have other ideas. So thank you.
Thank you very much.